Hello viewers, you are welcome back to Tindanius IBM YouTube channel. Subscribe to this channel kindly and share it to others for more interesting videos. Okay, we are going to continue from where we ended. Physics, dimensional analysis, or dimensional method, or dimensional equation. You get it that way? Now, we spoke about dimension, how to take the dimensions of basic or fundamental quantities, and today we are going to consider derived quantities. Okay, dimensions of derived quantities. Now, how do we go about it? To take the dimension of a derived quantity, first and foremost, express the derived quantity mathematically. Are you okay? Express it mathematically. So, for example, when I have area over here, let's say if I have work, it's a derived quantity. If I want to take the dimension, what do I do first? I will express work mathematically. So the formula is what? Force times what? Times the distance moved in the direction of the force. This is the first step. Now, second step, this is what I will do. I will take the dimension. Because I'm taking the dimension of work, what do I do? I'll put the square bracket to mean that I'm taking the dimension of what? Work. Then I'll take the dimension on the left hand side as well as the right hand side. So I have force here, so I also take the dimension of what? Of the force times the distance moved in the direction of the force. I'll also what? Take the dimension. Are you okay? So this is basically the two notable steps you have to know under the derived quantity, how to take the dimension. First, express the quantity, the derived quantity. Secondly, just take dimension of the derived quantity and you are free to go. Let's take examples and let's see how it goes. The first example I will consider here will be, let me take area. Okay, let me start with area. So area. So take the dimension. Well, what is the dimension of area? You know, area is what? Is a derived quantity, right? So what do? Just write the expression for area. So mathematically, area is what? Is length times what? Times your breadth or your width. Then, secondly, what do? What shows that I'm taking the dimension of the quantity called breadth? What shows I'm taking the dimension of this? Unless I put the quantity in a square bracket to mean that I'm taking the dimension. So I'll do this way. What you do to the left hand side, do the same to the what? To the right hand side. Are you enjoying it? Then let's proceed. So I'll take the dimension over here, take the dimension over here. So I have my area, the dimension of area equals. Now I've written the dimension of length. What's the dimension for length? Remember, separation. Length forms part of what? Separation. And what is the dimension of separation? It's what? It's capital L. If you want to understand more under the separation, you can visit the previous video I did on, or the introduction to dimensional analysis. Okay, you will be okay over here. Then times. Now, what is the dimension for breadth? Again, breadth is also what? A separation. And all separation, their dimension is what? Is capital L. So this one will be capital what? L. Do you get it that way? So my final answer becomes L times L will give me what? L to the power what? 2. According to the law of indices, exponent 2, exponent 1. The bases are the same. You pick one, then you add the exponent to 2. So this is the first example. So this is how to take the dimension of what? Of area. As simple as that. Let me consider the second example. My second example, of course, when you have area, of course, you know that the second thing I will give is what? Is volume. So let me consider volume. So I have volume over here. If I want to get the dimension of volume, I will express volume mathematically, which is what? Length times what? Times breadth times what? Times the height. Are you okay? Then I'll take the dimension for volume over like this. I'll put them in square bracket to mean that I am taking the dimension. Then I'll come here. The dimension for the volume becomes L again is separation, so capital L times L, this breadth is also what? Separation, so capital L times height is also a separation, so capital what? L. So hence, the dimension for volume is what? L to the power what? 3, L cubed. As simple as that. Someone will be saying, but volume has different formulas. Of course, it has different formulas. When you use those formulas, you still arrive at L to the power 3. Do you get it that way? So no matter how the formula is, you will still get this. So this is dimensionally what? Correct. So area, we use length times length. So we had this, right? Someone can also say area, the person we use L times L, right? Or L times B, length times breadth for the square, what have you, or rectangle. You can even use the area of a circle, pi r squared. Pi, this is a constant, so this is a dimensionless constant. We'll talk about dimensionless constant, okay? This dimensions, so r is radius. You know that radius squared is the same as radius times radius. And what is radius? Radius also is what? It's a separation into what? L, and there's a square over here. Do you get it that way? So basically, so no matter how you express the quantity in its mathematical form, when you find the dimension on both sides, you get the dimension of that quantity. It doesn't matter the formula you are using. Are you okay? So even for volume, someone will try to use pi r squared h. Are you okay? This means the volume of a cylinder is this. This one is dimensionless, so we ignore. So so we work on the r squared h. My r again is what? Is a separation. So it will be L to the power what? 2. I have my h. H is height. Height is also what? A separation. So times what? My L. What do I have? Is it not L cubed? Please, do you get the concept? That's it. Let me consider the third one. The third one, density. Density mathematically can be expressed as density mathematically is what? Mass over volume. Second step, the second step, what do? I'll take dimension of both sides. So I'll do this to mean I'm taking the dimension. I'll take the dimension of mass. I'll take the dimension of what? Of volume, 90. Then I'll come here, I'll write density. The dimension for density equals, what's the dimension for mass? It's what? Capital what? M over. Now what is the dimension for volume? We've done it already, which is what? L what? Cubed. Then, you know that according to the law of indices, when I have A over B, this is the same as A times B to the power negative 1. This has an exponent of 1. So when I transpose it here, it becomes negative. So this will be, my numerator will be constant, which is capital M. Then I'll transpose this over here. It will go L to the power negative 3. So this is the dimension of what? Of density. Follow and subscribe for more interesting videos. I'll solve another examples under the dimension of derived quantities. See you next time. Bye.